All right, stats, just 2 days left. This is the second half of your Chapter 1 review, where we're going to go over these sampling methods, kind of talk about them, what they might look like, and then we're also going to talk about some problems that happen with each one. So going through these, I'll list what they are, and then I'll list kind of an example, and we'll go from there. So before we do the types of sampling, let's talk about experiment versus observation. So in an experiment, uh, you have two groups. One that is the control and placebo group. Okay, so you have a control group and a placebo group. The control group is the one that you are doing something to. Okay, so we have to be, must be doing something to one group. Okay, so that means we're making them take a pill, or we're making them act a certain way or exercise a certain way. That's what an experiment would look like. An observational study, though, so even though you are like in an experiment doing observation, before you observe the two groups and collect data from the two groups, you are doing something. In an observational study, you're just looking at people and seeing what happens. So um, just watching. Okay. So for example, in an observational study, one thing that I want to do, sometimes they will lump these into three categories instead of just two. So they'll say experiment, observation. Sometimes they'll also do a survey. So survey, experiment, observation, those are kind of the three main types of data collection that you do. So in a survey, you're just asking questions. I'm going to add that over here, ask questions. Okay, so that's kind of a third type, experiment, observation, and then a survey. So you're just asking questions in a survey. In an observation, though, you're observing people's behavior. You're observing, how they react. So what I could do is, I could, let's say I'm trying out a new recipe and I want to collect information on, how well these people like this recipe. Okay, so what I could do two different things. I could either feed them what I make from this new recipe and then ask them questions about it, like how did you like it, what did it taste like, that type of thing. Or I could sit them down, have them eat whatever it is that I cooked, and then observe their reaction to it. Now, what I'm probably likely to get is more accurate data if I observe like their facial expressions as they eat the food. Maybe some of them spit it back out. I don't know. Um, Rather than a survey, because if it's one of my friends that I'm giving this food to, they might lie to me and say, oh yeah, it tastes great, whatever, even though they're lying. So in that case, I might want to do an observational study instead. In addition to that, I know that we've talked about the hand washing example before, where you want to observe people, maybe set a camera up in the bathroom just to aim at the faucet to see whether they are washing their hands or not, or are they washing their hands the correct amount of time, because some people go in and just dip their hands under the water and they're done. So they're not technically washing their hands the way that they're supposed to. But if you ask them if they're washing their hands, they're going to say, yeah, oh yeah, I wash my hands all the time. Well, are you doing it correctly? We need to observe how you're washing your hands to make sure that you are doing it right. Another one would be like, asking women their weight. Women lie all the time about what their weight is, especially if they're overweight. So rather than asking them and doing a survey, I'm going to actually have them come up and stand on a scale and me record the data. Now, some people think that that's an experiment. I'm not actually doing anything to them before I ask them what their weight is. Even though I'm making them come stand on the scale, I'm not actually doing something to affect their weight. Okay, so I'm just observing the scale and what it reads as they step on it. So observational study would be like, I'm going to put example, hand washing, or weight. I'm going to have them stand on a scale, that type of thing. So that's an observational study. So experiment versus observational study, and then a lot of times survey is lumped into that category also. So those three types, okay? All right, simple random sample. Let's go through these. Simple random sample. I'm going to say each, what do I want to say? Each item has equal chance of being picked. Okay, so this might be drawing out of a hat. Draw out of hat. A random number generator. So maybe you list everybody in order, in alphabetical order, and you have a random number drawn out of a hat, and that person is the person who wins. All of that is done completely random. No groupings are done before that. Okay. A systematic sample would be choosing every, let's say, nth person. Okay, and what I mean by nth person is like maybe I choose every person. I choose every fifth person, okay, in the class, okay. So what I do is, let's just do this, choose every fifth person in class, okay. And I'm going to say start with random number. So there are, I think, 33 students in the senior class. So I would start with a random number, and let's say I pull out the number 12. Okay, so I'm going to start with the 12th person. Okay, so let's say start with 12. Start with the number 12. Okay, and then I'm going to, after I do that, I'm going to go 12. I'm going to go every fifth person after that. So I would go 12. If I add 5 to that, that's 17. If I add 5 to that, that's 22. If I add 5 to that, that would be 27. If I add 5 to that, that would be 32. Okay. Now there's 33 kids in the class, so technically adding 5 to 32 would get me back at 4. Okay, because I would go 33, 33, number 1, number 2, number 3, number 4. That would be the fifth person after 32. Okay. And then that would be 9, and I would continue on again until I have, as many people selected as I needed. Okay, so I would start with a random number and then do every fifth person after that. This might be used, this is likely used a lot of times in assembly lines to check to see if products are working or not. So if I'm, producing batteries, if I have a factory and I'm producing a certain type of battery, maybe I would want to check every 50th battery going through the batch just to make sure that it is juiced up and there's nothing wrong with the battery, because if I have something wrong, then maybe I had a bad batch in there, okay? And I don't want to sell something that's bad because then people are going to complain. Okay, convenience sample. I'm going to say groups already made or data already collected. Okay, it is not very much work for me to do a convenience sample. So an example of this would be like getting heights from physical forms from the office. Okay. Heights from physical forms from the office, that data has already been collected, so I can just easily pull everybody's chart and get that data. Otherwise, I could do a volunteer survey, okay, where I like post it online or something like that, and students voluntarily can give me their opinion, okay. So those are all examples of convenience samples. A stratified sample would be grouping grouping, let's see, grouping people, I'm going to say, then choosing a few from each group. Okay, so this would be an example like, let's say I have all the Blue Hill people lumped over here, and I have all of the Lawrence Nelson people over here, and I have all of the Red Cloud people over here, and I have all of the Kennesaw people over here, and I have all of the, I don't know, what's another one, Harvard people over here, okay? So those are 5 schools in our conference. After I have them lumped, then I'm going to take 3 from each. So I'm going to collect data from 3 people from each of the schools. So that gives me kind of an equal representation from each one of the schools. Okay. All right. And then the last one is a cluster sampling. Cluster sampling. So I'm going to say grouping people, just like we did in the first one, but then choosing a few whole groups and forgetting the rest. Let's see, get this all on here. So I'm grouping the people, and then I'm choosing a few from each of the groups and forgetting the rest. Okay, so that would be like Blue Hill, Lawrence Nelson. If I do the same groupings as before, Red Cloud, Kennesaw, and Harvard. Okay, and let's say I'm going to choose Blue Hill because I have easy access to those people. We don't care about Lawrence Nelson, so we're going to get rid of them. We don't care about Red Cloud. Let's choose Kennesaw, and let's choose Harvard. So we're going to choose those 3 categories and just forget about everybody else, okay? And just gather data from those people. So that is an example of cluster sampling. I put them into clusters, and I choose the whole cluster, okay? So out of these, the very, very, very best method, I'm going to put this in a different color because it's really important. Very, very best method is to do this one, is to just completely do a random grouping and just randomly draw out, people, okay? So as I go through these, let's talk about some bad things. Choosing every 5th person starting with the 12th person, okay? So when I'm going in an assembly line, the problem with that is maybe I had a bunch of bad batteries in between every 5th one, okay? So that wouldn't necessarily give me a very good idea of which ones were bad because maybe I'm choosing the wrong, by choosing every 5th battery, maybe there's a few of them in between that are bad that I don't take into consideration. So a systematic sampling might not be the best decision to do. Also, maybe I choose to do every 10th person, okay? But a pack of batteries is 5 in a pack. Well, I could have all 5 of those. Maybe I'm choosing my intervals to be too large. So every 10th person, maybe I needed to actually only do every 5th person, check every 5th battery, okay? So maybe I needed to run more frequent checks than every 10th battery or every 15th battery. Maybe I need to limit it down to every 3rd person in the senior class, okay? So it's hard to know sometimes what your N should be in this case. So that can be a problem with systematic sampling. Convenient sampling, getting the heights from physical forms. Who fills out a physical form? All the athletes or anybody who's going to be in sports. If you're not going to be in sports, you don't necessarily have to have a physical. So maybe we're just getting all of the tall people, because maybe all of the tall people are the ones going out for sports. Little shorties like me are probably not going to, maybe not going to participate in any sports because we're too short and we just don't feel like we would make varsity. So, that could limit, that and put bias into that category. A volunteer survey we've talked about before, you don't ever want to collect data from a volunteer because they are either going to be strongly for or strongly against whatever you're talking about. Okay, you're never going to get anybody in the middle who's kind of one way or the other. They don't really care. Okay, you're going to get strong opinions in that scenario. A stratified sample. So where we have the groupings and we take 3 from each, okay? Now, using all of the schools in our conference, most of the schools in our conference are the same size as what we are. Red Cloud is a little smaller. Lawrence, Red Cloud and Lawrence Nelson are probably both a little bit smaller. Harvard, I think, is maybe about the same size. I don't know. You guys would know this better than I was. But if I'm taking 3 from each, okay? Let's say instead I do Blue Hill, Lawrence Nelson, Red Cloud, Kennesaw instead of Harvard. I'm going to do Omaha, okay? Now, Omaha is a lot bigger school than what these other 4 are going to be. So taking 3 students out of the Omaha district and 3 students out of every other district is not going to equally represent Omaha because they are a larger population. So a stratified sample might not be the best in this case. And then cluster sampling, you can kind of see why that would be bad because, you wouldn't get any opinions from anybody from Lawrence Nelson. And maybe they have a different opinion than Blue Hill. We wouldn't get any opinions from anybody from Red Cloud. So we need to take those people into consideration as well. So there's good and bad for each one of these except the simple random sample, which is probably the hardest one to do, to randomly draw out of a hat, that type of thing. This is probably the best scenario to go with, okay? So all of that stuff that we talked about in chapter 1, we've got 1 video left. Stay with me. We're so close.